and welcome to my mathematics class. Today also we are doing evaluation of limits of algebraic function, but not part 1, part 2, but we are in part 3. So part 3 means I have taken different type of question today to evaluate the limit of function. Okay, so you can see here nature question, nature function here. So compute the following limits. If you see the question, you will find out in function there is radical sign. Okay, so let's say today we will do this type of questions. So definitely you are gonna get ideas how to find out the limit of these questions. Okay, here we go. First question. Solution. Limit of uh, under root x plus a minus under root of 3x minus a with a radical sign whole upon x minus a as x tends to a. Or if you substitute instead of x, a, you will find out 0 upon 0 form. Let's see here. Root a plus a minus root 3a minus a over a minus a. Or root 2a minus under root 2a whole upon 2. Okay, sorry. Here 0 and 0 upon 0. We can write down whatever form we have here. Form 0 upon 0. Form 0 upon 0. Form 0 upon 0 means we have 0 upon 0 indeterminate form. Okay, as you know already, if we have an indeterminate form, this means we have to simplify. Today, okay, we have to use different approach to simplify this question. So whenever we get the radical sign, we use rationalization. Here in numerator, so we'll try to rationalize the numerator. So this means we have to multiply up and down by conjugate of the numerator. What is the conjugate of this? Okay, uh, conjugate of root a plus root b is root a minus root b. Conjugate of root a minus root b is root a plus root b. So here we have to multiply up and down by the conjugate of numerator. Alright, is equal to this limit of just multiply up and down root a and minus okay, here 3x minus a into conjugate of this plus 3x minus a x minus over x minus a into root x plus a plus root 3x minus a. Now as x tends to a is equal to limit as x tends to a of your, if you simplify you will get okay, x here a whole square minus under root 3x minus a whole square. X minus a into root x plus a plus root 3x minus a. Here which one formula we have used here, you can see a square minus b square means a minus b into a plus b. Using this, we have a minus b into a plus b. We can write down a square minus b square. The same thing I have written here also. Sorry, this is only just x. Limit as x tends to a of here it's gonna be x plus a minus 3x minus a. Here why I have written bracket, because here is negative sign. because whenever we open the bracket, sign will be changed. Otherwise, you can write down directly here plus. If you know, if you have a well idea, then no need to put bracket. If you have a confusion, without any confusion you can do, then you may write down also directly. Or limit as x tends to a of your x plus a. Just open the bracket. Where if you open the bracket, we will get minus 3x and plus a simple algebra here, x minus a or into root x plus a plus root 3x minus a. Limit as x tends to a, or x minus 3x means minus 2x here plus 2a, x minus a and into root x plus a plus root 3x minus a. Alright, different type of 3x uh, written here 3, so 3x, right? Any problem? I don't so think you are getting problem. Is equal to a limit as x tends to a. Here minus 2 common, minus 2, if we take common x minus a and x minus a, or root x plus a plus root 3x minus a. Okay, now we can, I'm writing here, this will cancel out. Excuse me. Minus a limit as x tends to a minus 2. We can cancel out because x minus is not exactly 0 upon root x plus a plus root 3x minus a. If you see, this is not now in indeterminate form. Okay, so if it is not in indeterminate form, we can substitute the value of x as a minus 2 whole upon root a plus 3a minus a. Now I'm moving this side. Okay, let me erase this part. And again we are here. I don't have a so big whiteboard. So anyway, it's working. Is equal to minus 2 upon root 2a. Alright. And plus root 3a minus a means root 2. Okay, like term. Minus 2 upon, we can simplify to root 2a. Okay, so finally we got minus 1 upon root 2a. So this one is your limit of this function. This way we can find out the limit of function. Okay, everybody? So I think you fully understood how to find out the limit of this type of function. Okay, the function have a radical sign. Okay, these are called radical sign. Second also same. So I'm going to leave this question for you for practice. As you know, I always emphasis is on practice. More practice, more practice. Definitely, you're gonna be perfect one in mathematics. All right, third one. So a third question is a little bit different than these two questions. If you observe all these questions, you're gonna find here radical sign only in numerator. In this question also radical sign in only numerator. So one question, first one I have done. So for second you can do similar type of question exactly. And third one you're gonna find here radical sign in numerator as well as in denominator. So let's see how to do this type of question, right? So both here also same type of radical sign here, radical sign here. Now I'm going to tell you. So don't worry, I'm going to make it easy for you. Okay, so here we go. Question number third. One third. Question number one. Yeah, one third. Limit as x tends to a. Here also a. Coincidentally, first three I have taken as limit x tends to a. Alright. Okay. Let me write down the question. 2x minus root 3x minus a root x minus root a. Here, in first question, we have just rationalized numerator. Here, radical sign is in both numerator as well as in denominator. So that's why we need to rationalize from both. Means I mean to from numerator as well as a denominator. We have to rationalize. Okay, whenever you get radical sign in both, especially in evaluation of the limits of the algebraic function, you can rationalize, right? Okay. So see. Rationalize means you need to multiply up and down by conjugate of this as well as up and down by the conjugate of denominator. Alright, conjugate of denominator, conjugate, I think you understood. Conjugate means root 2x. Conjugate of the numerator is root 2x plus root 3x minus a. Conjugate of denominator is root x plus root a. Okay, here we go. Multiplication work. Root 2x is a 2 minus root 3x minus a here root 2x plus root 3x minus a here minus, and now here denominator is root x minus root a, and here so root 2x you are going to multiply up and down by root 3x minus a. And now as I told you, just we have rationalized numerator. Now let's rationalize denominator also. Root x plus root a, multiply up and down by conjugate over this one, root x plus root a. Okay, so clear, right? You are familiar, I think, with all these work. And the next task, limit as x tends to a. Now let's simplify. Here also we'll use here a minus b, a plus b, a square minus b square formula. Here a minus b, a plus b. So we can simplify these two. We can apply formula a square minus b square, right? A minus b, a plus b is equal to a minus b. Okay, 2x minus 3x. Now, okay, whenever we use a square minus b square, radical sign will be removed. Here minus root 3x minus a whole square means radical sign will be removed. They are inverse of each other, so they cancelled. They will cancel out, and sign will be changed. Okay, as I told you in this question, minus 3x plus a. It's gonna be plus a. Okay. All right. So let it be same. Okay. It's not going to make any difference. Means it's not going to bring a mean to indeterminate form. It's we are safe. And let me tell you, okay, just indeterminate form. Okay, I got it here to write form 0 upon 0. I think no need to explain why I have written here 0 upon 0. When you will substitute a here, you're gonna get 0 upon 0. Alright. Okay, let's simplify the denominator. Simplify denominator here, root x minus a, root x plus a square minus b square formula. By a square minus b square formula we got x minus a. So definitely at this level you will understand the simple things, right? Okay, root 2x plus root 3x minus a, same. Alright, limit as x tends to a of this function, whole function, here minus x plus a, and here so same. Okay, you write down, no need to disturb it, and this also not creating problem. Here x minus a, same, 2x plus root 3x. Oh, okay. Oh, one thing I have done mistake here. I came to know how is it possible the same thing okay here also, right? After simplification here. Okay, honest mistake here. Mm, okay, I beg to pardon. Uh, Let me write down here. Okay, here we have applied here. It's gonna come here. Okay, root x plus a. Now it's alright. Now it's alright because we applied okay formula here. Now here okay these two simplify to this expression and this one we will write as it is, and here also root x plus root a. Okay. No, it's alright. Absolutely right. Alright. So once again, let me recap. Uh, Let me explain again here, just up and down. We have rationalized from both sides, numerator as well as denominator, because in both we have a radical sign. Okay, radical sign. Okay, we have to multiply up and down by conjugate of this. Okay, multiply, and also we have to multiply again up and down means numerator and denominator by conjugate of this. Okay, multiply, and these two simplified. We have applied a square minus b square formula. A square minus b square means a minus b plus b. We can write down a square minus b square. Whenever we use okay square minus b square, you're gonna get okay 2x minus 3x plus a, and here so root x plus root a. Okay, it's not creating any problem. And here these two will be simplified because they are in product and also in the form of a minus b a plus b. Okay, x minus and root 2x same. Okay, this also not creating any trouble. So alright, x minus, okay, here 2x minus 3x minus x plus a. Okay, same. Alright, now limit x tends to a, here minus common x minus a, or root x plus root a, and here x minus a, and root 2x plus root 3x minus a is equal to, now they will cancel out because you know right, x minus a is not equal to 0, x tends to a. So x minus a is not equal to 0, x tends to a, minus negative sign, the negative of root x plus root a, and here root 2x plus root 3x minus a. Now this is not in indeterminate form, alright. So let's find out the limit. Finally, we are at the point where we can find out the limit of this function. I'm happy because at least I'm doing okay mathematics for you. Alright, so minus 2 root a upon root 2a plus, okay, it's gonna be root 2a, and here is equal to minus 2 root a upon 2 root 2a. To do cancel, they can be cancelled, and root a upon here. Little bit simplification we can do here, and we can write down okay like this way, 2 root a into root 2. So root 2, I meant to root 2 into root a, and cancel here negative sign. So finally 1 upon root 2. So this is your limit of function. Okay, clear everybody? So I think so all you understood how to find out the limit of this type of function, right? Okay, this is for practice for you, and you can do very easily. Here also you can use okay same method, right? You can just okay these two question, same type of question. This one I have done, this one also I have done, and this one question you can do yourself, right? And let me provide you more questions for practice. As you know, okay, practice, and mathematics will definitely enter in your brain. Okay, so alright, now let me write down the equations for you. I've written questions for you for practice. Questions for practice. Evaluate the following limits. I've given for you 8 questions. 1, 2, 3, 4, 5, 6, 7, 8. 8 questions, and today first time I've given answers also for you. It will be easy to you to check whether you have done correct or wrong. If wrong, you can try again. All right. But these all questions are easy, not so difficult. If you try, definitely you will gonna get okay answers of these all questions. Okay. See, here very easy. Just you will multiply conjugates of numerator up and down. Up and down means here numerator and denominator. You just firstly simplify by taking LCM and then rationalize. You just conjugate of denominator by up and down here, conjugate of numerator up and down here. Okay, you have to multiply up and down by conjugate of numerator as well as the conjugate of denominator, as I told you the one question. Okay, same exactly in the same way you can go. Here also same, conjugate of numerator up and down, and conjugate of denominator also, right? You will use to multiply up and down, right? Same here also, exactly same nature. Here also same. Here also you can multiply up and down by the conjugates of numerator, and again you can multiply up and down by the conjugates of the denominator, right? Because radical sign we have in denominator as well as in numerator, right? No, yes. I think okay, I told this one, so in numerator as well as in denominator. Okay, so you can use, okay. I have given questions for you, whatever I explained today, right? So go through each and every question. So definitely you will get the result of all questions. Okay. So I think okay you will definitely practice, and while practice, I hope you will get to enjoy and doing the limit evaluation of limits of algebraic function part 3. So don't forget to share also to your friends, or ask your friends to subscribe and share the channel. I want so more and more students should be benefited from this class, from my mathematics class. Okay, so thank you very much for watching. uh, Till next video, bye bye, take care, have a wonderful time.